Welcome to qnawire.
Okay, so we're doing chapter 34, problem 59 here. So it says the focal length of an eyepiece for a microscope is 1.8 centimeters, and the focal length of the objective is 0.8 centimeters, separated at a distance of 19.7 centimeters, as all shown in this figure over here. So treating all of the lenses as thin lenses, part A asks, what is the distance from the objective to the object being viewed? So first we need to realize that for this microscope system, the final image is at a distance infinity, because that's how we define these at. So if we're working backwards from the second lens case, if we plug in our equation, we see that the object distance is equal to the focal length. So the object distance is 1.8 centimeters to the left of eyepiece. So this object is also the image formed from the objective. So we can set up the next thing. So let's write this down. So I'm going to call this image 1, because this is not the final image, this is the image between them. So we're going to call this right here, and I'm going to say this is image 1, and it is 1.8 centimeters away to the left of the second lens, and that makes it 17.9 centimeters to the right of the other lens. So this being object distance for the second case, and this, object distance for the second case, and this being the image distance for the first case. So now we know where the image is formed from the first lens. We're working backwards again, so we're trying to get to where the object is. So we can use our thin lens equation, rearrange for the object distance. So we're trying to solve for this, which is s prime f over s prime minus f. So we can plug that in. So 17.9 times 0.8 and 17.1. And this is equal to 8.37 centimeters. Oh, sorry, that's not centimeters. That is actually, if we're doing in centimeters, so we did the rest in centimeters, so we're going to keep that, and this is 0.837 centimeters, or 8.37 millimeters. Cool. So that's the distance it is. It's around 8.37 millimeters to the left of the first lens. So part B asks, what is the angular magnification? Oh, sorry, wrong question. What is the magnitude of the linear magnification produced by the objective? So to do that, we obviously know we can relate the image distance over the object distance here. So that is negative 17.9 over 0.837. So we plug that in, and that becomes a magnification of negative 21.4. Awesome. Negative because it is inverted. So part C asks, what is the overall angular magnification of the microscope? So from this, we can use the equation 3423, relating the total to the linear of the objective, M1, call that M12, times M2, where M2 is given as 25 centimeters over F2. So let's go ahead and plug that in, which is 25 centimeters over 1.8 centimeters. So this is 13.9. So that means our overall magnification is negative 21.4 times 13.9. So if we plug that in, we get a negative 297 for our magnification. So yeah, this microscope magnifies roughly 300 times, which is very, very good.